In this video, we can learn the next type of literal, that is the numeric literals. So we know that it is the third type of tokens literal. In literals, there are string literals, numeric literals, boolean literals, special literals, and literal connections. Now here we are going to discuss about the numeric literals. In numeric literals, first one is the integer literal. We know that the numbers like 1, 2, then 12, 22, 25, then plus 27, minus 28 are known as the literals. Now, integer literals are again divided into three. First one is the octal numbers. That means integer literals can be represented as octal numbers, then hexadecimal numbers, and binary numbers. Now, octal numbers are represented as 0, O, then we can write the octal numbers. We know it ranges from 0 to 7. So we can write 2, 5, 6. It is an octal number. Or 0, O, 3, 1, 2. It is an octal number. Or if you write it like this, 0, O, 2, 8, 9. It is an invalid representation because octal number ranges from 0 to 7. Next is the hexadecimal representation. In hexadecimal representation, it is like this. First we have to write 0. Next we have to write X. Small letter or capital X we can use. X. Then we can write 2F3. That means hexadecimal numbers ranges from 0 to 9 and A to F. So it is an hexadecimal number. Or 0x57b. So in this way we can represent the hexadecimal numbers. Now next is the binary numbers. For binary numbers, we know it is a combination of zeros and ones. So first we will write 0. In order to represent binary, we will use B. Then we can write the combination of zeros and ones. So this is an binary number. So octal, hexadecimal, binary. All this will come under the integer literal. Now next is the floating point literals. Actually, the floating point literals is of two types. First one is the fractional form. First one is the fractional form and second one is the exponent form. First one is the fractional form and second one is the exponent form. Fractional form means we are writing point parts in a number like 25.67. So 0.67 is the fractional part or the point part, or 9.8, 0.03. These are the fractional numbers or the fractional form of floating point numbers. Second one is the exponent form. We know how to write the exponent form. For example, 3.8 into 10 raised to 8. That means here 10 raised to 8, it is in an exponent form. And these are also known as the real constants. These are also known as the real constants. Now, we can write like this. 0.58 into 10 raised to 2. Now, I want to represent it in the exponent form means we can write like this. 3.8. Exponent form. Exponent is represented by capital E. So we can write E 0.8. That is 10 raised to 8. Next 0.58 into 10 raised to 2. So we can write like this. 0.58 capital E 10 raised to 2. So we can write 0.2. Or if you are writing like this. 0.76 into 10 raised to minus 3. So we can write 0.76 E minus 0.3. In this way, we can represent the exponent form. Or if you are writing like this, 87 into 10 raised to 2. So it will be like this, 87E02. So in this way, we can represent the exponent form. So this is the floating point literal. Floating point literals can be represented in two ways. First one is the fractional form and second one is the exponent form. Now it is having two parts. This exponent form is having two parts. First one, 3.8. This point part is known as the mantissa. The point part is known as the mantissa, and 10 raised to 8. This part is known as the exponent part. So an exponent form is having two parts. First one is the mantissa part and second one is the exponent part. Now if you are writing like this, 1.7e, it is an invalid representation because we didn't write the exponent. I mean, we didn't write the 10 raised to 2, 10 raised to 3, like the numbers will be coming. That is not represented here. That means it is invalid. After E, there is no integer value. After E, there is no integer value. Now next, if you are writing like this, 0.7E 2.3, this is also invalid because exponent cannot have fractional part. Now see here, after exponent we are writing 2.3. 2.3 means in Python it is known as the fractional part. So exponent cannot have fractional part. Exponent cannot have fractional part. Next, 17,225E02. This is also invalid because while we are writing exponent form, there is no comma. Or in Python, it is not. If you are writing a number, we should not use comma. If you are writing numbers, we should not use comma. So it is invalid because comma is not allowed. Comma is not allowed in Python. Now, next set of value is the complex number. Next set of value is the complex number. In complex number, it is of the form a plus b I. It is of the form a plus b I, and it is having two parts. First part is the real part and second one is the imaginary part. First part is known as the real part and second part is known as the imaginary part. It is represented as IMAG, imaginary part. Suppose we are writing a number like this, a equal to 5 plus 6, a equal to 5 plus 6j. It is a complex literal. Now I want to represent this number. I want to get the real part of this number. So we can write like this, print a dot real. Then we will get the value as 5.0. Or we can write like this, print a dot imaginary part, IMAG. Then we will get 6.0. In this way we can get the real and imaginary part. Suppose we are writing like this, a equal to 5 plus 6j, b equal to 2 plus 3j, then c equal to a plus b. Now the print c. Then we will get the result like this. The real part will be added together and the imaginary part will be added together. So the output will be like this. 5 plus 2, that is 7. 7 plus 6 plus 3, 9. 7 plus 9j. In this way we will get the result. So this is the complex literals in Python. Now next is the Boolean literal. Boolean literals means true and false. In Boolean literals, true means 1 and false means 0. Now next is the special literal. Special literal is the none. None means it indicates the absence of a value. For example, I am writing like this, a equal to none. That means a is a variable and it points to a none value. That means there is no value inside that space pointed by a. So it indicates the absence of a value. None means nothing. It indicates the absence of a value. So this is all about the literals. So in literals we have learned integer literal, floating point literal, complex literals, boolean literals and special literals.